If you've studied wartime survival long enough, you eventually run into devices that look almost too simple to matter. But then you realize they kept men alive in conditions where failure meant death. The WWII heat rack that cooked without fire is one of those devices. It rarely appears in glossy documentaries, yet it was quietly relied upon by soldiers, resistance fighters, and civilians who could not risk smoke, flame, or wasted fuel. Today I want to walk you through what it was, how it worked, and why it still matters to serious historians and preparedness-minded people who study low-signature survival. Picture the problem faced in Europe and the Pacific during World War II. Open fires drew attention from aircraft, patrols, and snipers. Fuel was scarce, often rationed or non-existent. Trenches, foxholes, armoured vehicles, and bombed-out buildings offered little ventilation. Yet men still needed hot food, warmed rations, and sometimes, the ability to thaw frozen supplies. The solution was not always a stove. In many cases, it was a heat rack designed to capture and reuse waste heat that was already present. The introductory hook here is simple and, uncomfortable. Thousands of meals during the Second World War were cooked just inches away from engines, exhaust systems, and metal housings already hot enough to burn skin. No extra fuel, no visible flame. No smoke plume to give away a position. The heat rack wasn't a gadget of comfort. It was, a tool of survival, discipline, and tactical awareness. Why militaries needed a way to cook without fire during the Second World War? Armies quickly learned that fire was a liability. In North Africa, a single cooking flame could be spotted for miles at dusk. On the Eastern Front, fuel shortages meant men often went days without proper heat. In armoured units, crews lived next to engines, producing enormous amounts of waste heat. That heat normally disappeared into the air. Engineers and soldiers alike began finding ways to reclaim it. Heat racks appeared in several forms. Some were officially designed, others improvised in the field. Tank crews mounted metal racks above exhaust manifolds. Truck drivers welded frames near engine blocks. Field kitchens adapted racks that sat above enclosed stoves, allowing food to cook slowly without open flames. In resistance movements, civilians used stove chimneys and boiler housings with metal shelves hidden inside walls. What matters historically is that this was not cooking as we imagine it. It was slow, controlled heating using surfaces that already existed. At its core, the heat rack was a passive heat transfer system. Metal conducts heat efficiently. Engines, exhaust pipes, and enclosed stove bodies reach temperatures between 150 and 400 degrees Celsius during normal operation. A rack placed near or above these surfaces absorbed radiant and conductive heat. Food containers back then were quite practical, usually made of metal mess tins, wrapped rations or sealed tins. Bread, it could be warmed up nicely. Meat, on the other hand, could be reheated to make it a bit more palatable. Stews, they thickened slowly over hours, rather than minutes. You know, nothing ever sizzled, really. The absence of a direct flame, interestingly enough, meant that food cooked evenly, though admittedly it was a slow process. You see, tank crews often placed their rations on exhaust racks during those long movements. By the time the column halted, the meal was ready. German panzer crews, for instance, documented using exhaust-mounted racks to heat up sausage and bread. Quite resourceful, wouldn't you say? Allied forces did the same with tins of bully beef or stew. In winter campaigns, these racks doubled as thawing platforms for frozen supplies. Armoured warfare provides the clearest documentation. Tanks like the Sherman and Panzer IV produced enormous heat. Photographs show welded racks bolted to rear exhausts. These were not luxuries. Crews had limited space and limited cooking options. Logistics units used them as well. Supply trucks ran for hours at a time, and a rack near the engine bay allowed drivers to warm meals while on the move. In partisan warfare, improvised heat racks inside safe houses used chimney flues, allowing food to cook while appearing to be nothing more than normal heating. Even prisoners of war documented using similar principles, placing tins near boiler pipes or factory machinery. Hot food is morale. World War II diaries repeatedly mention the importance of a warm meal after long operations. Heat racks provided that without compromising safety. Soldiers could eat warm food without revealing their position. Civilians could cook discreetly during occupation. For anyone serious about low-profile survival, the principle still applies. Waste heat exists everywhere. Vehicles, generators, wood stoves, chimneys, and even solar-heated metal surfaces can be used safely with planning. In a modern blackout or fuel shortage, a vehicle engine can warm food without burning additional fuel. A simple steel rack mounted near, but not touching, the exhaust can heat sealed containers while the engine runs for necessary charging or movement. Inside a home, a wood stove chimney radiates heat long after the flames have died down. It's rather fascinating, isn't it? A discrete internal rack allows for slow cooking without the need for extra fuel. Quite ingenious, if you ask me. The key lesson from World War II is patience and control. It's not about speed, you see. It's really about efficiency and discretion. A valuable lesson indeed. Historical accounts stress the importance of spacing and containment. Food was never placed directly on exhaust pipes, you know. Containers were always sealed to prevent contamination. And, of course, heat exposure was gradual. Quite meticulous, wouldn't you say? These same rules apply now, you know. Overheating causes burst tins and spoiled food, which is just a waste. On the other hand, underheating wastes time. Crews knew exactly how long their vehicles would run and planned meals accordingly. That mindset, honestly, translates directly to modern preparedness. The World War II heat rack represents a mindset rather than just a tool. It's about using what already exists, minimizing risk, and, well, understanding heat as a resource rather than something that must always be created. It bridges military history and modern preparedness perfectly. It also reminds us that survival solutions are often quiet, unremarkable, and, deeply practical. They do not look impressive, they work. If you found this deep dive valuable, subscribe to The Prepper Historian for more overlooked survival history that actually teaches usable lessons. Share this with fellow historians and preparedness-minded friends who appreciate substance over spectacle. This channel exists to preserve and apply the hard-earned knowledge of the past, and your support keeps that mission alive.